Well, welcome everyone. As people start to connect, I'll provide a short introduction. So for those of you who do not know me, I'm Eric Shook. I'm an assistant professor in the Department of Geography at the University of Minnesota. I'm also the XSEDE domain champion for GIS and the University Consortium for GIS Science Education Committee vice chair. So from all of these hats, I'd like to welcome you to this presentation. Looking at the call list, we have a nice mixture of GIS folks who might be new to XSEDE and high-performance computing, as well as some XSEDE folks who might be new to GIS, and a few like me that sit at the intersection between high-performance computing and GIS. I think that this talk is going to be interesting and exciting for everyone on the call. To give a real brief background, Steve kindly reminded me of this. So this all started when we started seeing an increased interest from GIS users kind of hungry for HPC resources. So I sent an informal survey to the XSEDE champion mailing list, and it only had 3 questions. And we found over 80% of respondents rated the following kind of 3 items as either being very useful or somewhat useful. And those were information on GIS-related software for cyber infrastructure, including Esri ArcGIS products and Python and R packages, as well as training materials for GIS users for learning how to use GIS on cyber infrastructure, as well as training materials for the CI specialists to learn GIS themselves. So I think that there's been a lot of interest from both sides, and I think that this talk's going to be pretty exciting for both communities. And I'm hopeful that this is the first in many kind of GIS plus HPC activities that we'll see in the future. For a quick logistics note, the presentation is being recorded, and I'll share the link with everyone. If you're on the call, you should have probably received it on the various channels. Otherwise, my contact information will be on the slides at the end. And before we get started, I really want to thank Esri for agreeing to give this presentation. Having multiple people who you can see on the slides here available to present and answer questions related to both the technical installation and licensing issues, as well as kind of the scientific use cases. So I think that this is great. I particularly want to thank Steve Cope, who's answered many emails over months and months. The talk has been many months in the making. So I really want to thank him and all of his patience with me, and with me mostly. And last but not least, I'd like to thank the XSEDE leadership. So Nancy Wilkins-Zier, Sergio, Dana, I see she's on the call, Henry Neiman, for helping to coordinate this talk, and any of the pre and post kind of activities revolving around trying to get GIS users and GIS software available on the XSEDE supercomputers. So with that, I'm going to pass it over, and thank you everyone for coming, and we should have time for questions at the end.
Okay. Thanks, Eric, and thanks everybody for showing up over lunch, if this is your lunchtime. I'm Steve Cope, and we'll also have Shannon Kaliski from our product management team and Mansoor Rod, our big data advocate, on with us today. And this actually started a few years ago. I was involved with XSEDE, particularly through folks at Illinois and San Diego with the Cyber GIS project. And so Eric and Nancy and I have been talking for a while, and we've never quite gotten the traction in the relationship that that we were all sort of trying for. But things are a little different now, and I think it's good timing for having this conversation, because most research universities have a broad license agreement with Esri, which allows you to use an unlimited amount of our technology for a single price, regardless of how much you use. And that isn't actually widely understood, even within some people within Esri. But because people like yourselves that are responsible often for hardware within the university, and the other people who are managing the ArcGIS licenses within your organization or in different parts of the university, making that connection across making that bridge was difficult. So first off, I just want to clear up front that we're totally okay with you using as much of our technology as you want through your enterprise license agreement. So we encourage you to go big and solve big problems with our technology. We also have some new scalable spatial analytics software that we released at the end of last year that we're going to talk about today, which makes this also particularly timely. And as Eric mentioned, the interest in R and Python as well, which is also a collaborative project that we have going on. So we'll start off with Shannon providing an overview of just the ArcGIS platform and ArcGIS Enterprise to give us some context about this. Then Mansour and I will talk about the analytic capabilities, and we'll have some time at the end for Q&A. So Shannon?
All right, thank you, Steve. So like Steve said, I'm the product manager of ArcGIS Enterprise, and I'm going to be giving you a platform overview of ArcGIS, so all of that technology that you can take advantage of, and as well as ArcGIS Enterprise specifically, which Mansour and Steve will be talking about some of the capabilities we have within Enterprise. So getting started with ArcGIS, it really is a platform that delivers mapping and spatial reasoning tools for you. It doesn't mean that a map always has to be the end product. You can end with a Python notebook. You can end with analytics or report. You can end with any number of things. So maps are beautiful and a great resource to be able to see the spatial trends that are happening within your data. And all of our technology obviously integrates well with displaying your data in the spatial context. So the way you're going to experience the platform is through one of these 5 different areas of our technology. So diving deep into them, but staying high level, you have apps, which are geographically driven apps. They can do things like enable field mobility. So maybe you create an app for people to completely disconnect, go out in the field, gather information, and sync that back. Alternatively, you can make an app that you can deploy out to the community where people can use social media or just their own devices to be able to provide input on things that you're doing within the community, within the region, within the area. The scale's really up to you. And then also there's the apps that you'll use within individual businesses or within the university where you have apps that you want people to engage from their own offices and where they can collaborate that way. So we have a large suite of apps that can do many, many things. We also include the builders for those, so you can build custom apps without ever having to write a line of code. Then we have ArcGIS Online, which provides a WebGIS that's hosted by Esri, delivered as SaaS. So when we talk about WebGIS, what we really mean is a GIS that is using a browser. In the case of ArcGIS Online, it's specifically the internet. It's online lives in Amazon AWS. It is hosted by Esri. So we are managing that. We manage all the scalability with that. So just as an example, last month, the month of April, on average, ArcGIS Online served up 556 million map requests a day. And we see that spike in cases like we had PokeVision, which is an app that one of our users created to help people find Pokemon in the Pokemon Go craze. And during that time, we reached 700 million map requests a day. So obviously going well over, a billion into the billions of, just billions, let's leave it there, of map requests each month with ArcGIS Online. Other way. Then we have ArcGIS Desktop. This is where you really can dig deep into the analysis. It is a desktop application, and we have many, many geoprocessing tools that will allow you to do everything from advanced screening to interpolations to simple data displays. It's really up to you. So with ArcGIS Desktop, we have ArcMap and we have ArcGIS Pro. And ArcGIS Pro gives you the ability to integrate with a WebGIS, which could be ArcGIS Online, like I just described, or it could be ArcGIS Enterprise. So ArcGIS Enterprise is mapping and analysis server software. It includes a WebGIS portal, so you have that ability to create that collaborative space where people can come and create, organize, share, run analysis, all of that, but you control the infrastructure that it's on. So that can be in the cloud, that can be in your physical infrastructure, and we do support both Windows and Linux OS, so there's no problem there if you're a Linux shop. And then finally, there's ArcGIS for developers. This is the APIs and SDKs that can extend the desktop, it can automate your WebGIS, or you can even use them to build custom applications. So even though I said it's code-free on both apps and online, if code is your thing and that's what you want to do, by all means, we have the resources for you to be able to hit the ground running, creating very meaningful geospatial applications just right out of the gate. So ideally, we would like to see everyone using all of them, and you can. So what that looks like is you would obviously start with a desktop, run your analysis, create the tools that you want to be serving up and sharing. Then you would put it into some WebGIS. That can be ArcGIS Online, or it can be ArcGIS Enterprise. You can decide if you want Esri to manage the infrastructure, or in your case, it probably makes more sense that you would manage your infrastructure. And then create some sort of app that people can consume and make sense of it. This could even be something like the Insights application, where you can engage with the data in a new way, where it's really about displaying analytics quickly so you can detect these trends, and it's through a series of live cards. It's very interesting. It's a good way to discover the data and to see what's happening underlying very quickly. And of course, ArcGIS Developer for developers runs the whole gamut from desktop to apps, end to end. You can use the developer tools. So to simplify what WebGIS looks like, so for folks that want to get started just using completely Esri managed infrastructure, they would just deploy ArcGIS Online. They would just sign up, get an organization, just use that. Very easy to get started. If you want to stay completely within your own infrastructure, then you deploy ArcGIS Enterprise. And like I said, that's up to you on how you want to manage that deployment. If you want to put it in the cloud, if you want everything on one machine, multi-tiered, high availability, disaster recovery, we have deployment patterns that handle that. But really the pattern that we've been encouraging people to move towards is to use both ArcGIS Online and ArcGIS Enterprise. At our latest software release that will be coming out around our user conference time, we've introduced the capability to do distributed collaboration with ArcGIS Online and ArcGIS Enterprise. This means that if you have ArcGIS Enterprise and all that server compute running within your infrastructure, and you want to share that data out to an ArcGIS Online, so to the public, for example, you can do that very easily, having your feature layer data copy, or maybe just reference back to your services. And that way, people aren't hitting your immediate infrastructure, and you can take advantage of all the scaling that Esri does with ArcGIS Online. So those are your three options for WebGIS. And then obviously you have the apps. And to give you an idea of what I mean when I say that ArcGIS for developers runs the spectrum, you can see that with desktop GIS, we have ArcPy, which is a way that you can use Python to write geoprocessing tools and automate tasks within desktop. But we've also released the ArcGIS Python API, which you can see spans both desktop GIS and WebGIS. The Python API integrates with Jupyter Notebooks and the SciPy stack, so you can use the libraries that you're already used to using and just bring those in. And another great way is if GIS isn't your strong suit, you can use your Python notebook as your primary workspace. So you can embed the live map in there, and all of your changes are linked through that WebGIS. So through those web portals, you are being able to live manipulate your data, do administrative tasks, change groups, replicate content. There's a whole library on our developers.arcgis.com where you can see what the Python API can do. And then obviously in app creation, we have things for iOS, Android, .NET, or JavaScript. So wherever your app is going, be it mobile or in the web, you can have a language that will help you be able to get that job done. So now let's get into ArcGIS Enterprise. So, like I said, it's flexible server software for mapping and analytics. It allows you to take your location-enabled data or your GIS data if you already have GIS data, and manage that run analysis, and also bring a browser-based GIS to the
Ex-
portal.
Sorry, Shannon. Can
Yeah.
we have somebody mute their mic? We're getting a lot of background noise.
Oh, I think it's the person that has their camera on and their office is being vacuumed. It's okay. Office cleanliness is very important. So there we go.
Thank you.
No problem. That was great. Okay, back to ArcGIS Enterprise. So whatever data that you have, be it live data streams from an Internet of Things, a large collection of raster imagery, your vector, your business intelligence, big data, or even just a large collection of CSVs, we can handle that. There is a server capability that we can bring in, and almost every kind of data. So there, you do want to check to make sure, but in general, we can handle anything that can come in. And for the data that you don't have, because a lot of times it's great if you have your data, but if you don't have any data, you can still get started right off day one with ArcGIS Enterprise, because at 10.5.1, which is the release that we had in December, we started including the Living Atlas. So this means that even if you're using your own infrastructure to deploy the software and you want to manage that yourself, you can still have access to the foremost and largest collection of GIS curated by Esri to be able to bring this into your analysis. Not only that, you can take the Living Atlas layers and you can move them across the various aspects of the platform. So if you are using an app like Insights, you can bring in a Living Atlas layer and be able to use that in your analysis. If you're using ArcGIS Online, you can pull in that Living Atlas layer and run geo-enrichment on it. You can do many things with the Living Atlas that will help you dive deeper into your data, so that way you spend the time doing the analysis that you need to do rather than spending the time searching for data. So ArcGIS Enterprise organizes these capabilities that we offer into servers. They're not individual products. They are all actually part of ArcGIS Enterprise. But what we do is we group the capabilities by what makes sense. We start off with what we call the base deployment. So that's just the minimum configuration to get you started. It'll include a GIS server in there. And the GIS server handles all the basic things like being able to serve up the map services or feature services. It's what you need to publish from ArcGIS Pro, which is one of our desktop GIS applications. So that will be included in there. Mansoor and Steve are going to be talking about image server, GeoEvent, and GeoAnalytics server. And then we have business analyst server, which is really specialized for if you are trying to understand a market, if you're trying to look deeper there. And that's probably the least applicable for this audience, so we're not going to spend any time on that today. However, if y'all do have questions, you can reach out to myself, to Steve, to Eric, and we can get you that information. The ArcGIS Enterprise, like I said, has a portal. What you do in this portal, it is a browser-based GIS experience. So it can be completely disconnected from the open internet if you need it to. So if you have very secure or sensitive data, there is no reason that you need to connect to the open internet. This can completely be in your own infrastructure. But you can also deploy it to where you can connect to the open internet. And if you can connect to the open internet, you can start leveraging some of the services that come from ArcGIS Online, assuming you have an ArcGIS Online organizational account as well. So that can enhance the spatial analysis tools that you have within the portal. Desktop GIS, while the primary place to start creating analysis and doing that sort of work, is certainly not the only place. Within both ArcGIS Online and ArcGIS Enterprise, you can use that WebGIS environment through those portals to be able to access analytical tools. Now, unique to ArcGIS Enterprise is that through the Enterprise portal, you can access tools like raster analytics, which is distributed analytics and computing of raster and imagery data sets. You can also use geoanalytics tools, which is distributed computing on vector and tabular data sets. And both Mansoor and Steve are going to get into those, so I won't spend too much time on that. But I did want you to know that from within that portal interface, you can access those, which also means that if you're using the Python API and you're using a notebook, you can still call those tools and run those analysis from the Python API as well. So how do you deploy ArcGIS Enterprise? Is, like I said, up to you. It is software you install. If you're installing just a test environment, you just want to get something started really quick, really easy, day one, maybe you're just wanting to tinker around, I would really recommend using the ArcGIS Enterprise Builder. What Builder does is it will configure and deploy a fully operational base deployment, so that's all your software components of Enterprise, so including the portal, and configure that up. The only thing you have to do is set up the security certificates, and you're up and running. So you could kick it off, go to lunch, come to back, and you have an ArcGIS Enterprise deployment ready to go. Now, if all-in-one deployments are too small and that's not what you're doing, and you're doing a lot of repeat deployments, so maybe deploying on many, many machines, which I think would be probably very applicable for you, we really recommend using Chef. So on our GitHub page, we have a lot of Chef recipes already up there, and you can look through those, and it gives you a jump start to be able to set up your deployment and get going. And that way you have the record of what you did in the Chef script, but you also can now automate those tasks, making it a much easier process than having to do it by hand, which of course you are welcome to do if that's your thing. And then finally we have deploying in the cloud. Really, we can support anything that meets our minimum system requirements. So if using Amazon AWS or Microsoft Azure is not for you, that's okay. But our machine images we create for both AWS and Azure. These are bring your own license machine images. So it's ready to go. You pick your what kind of instance you want to spin up. So if you do have allocations in your grants for being able to use the cloud, getting started with Enterprise in the cloud, very easy. And all you have to do is bring your license and get going. It's the same setup across the board. So if you are going from base deployment to wanting to add on raster analytics, or if geoanalytics is particularly interesting to you, you can do that. You just apply the different license file. It's that simple. And so with that, that was our very quick crash course into what ArcGIS is as a platform, what ArcGIS Enterprise is. So remember, that's the server software component, which you can also extend through other extensions. It comes with the data. It has the Enterprise portal. And now I'm going to turn it over to Steve to talk on raster analytics. So this is now getting into a little bit deeper into what you can do analytics-wise with ArcGIS Enterprise.
Actually, we were going to do...
Oh, we're going to jump to Mansoor?
We're going to do Mansoor first. Sorry. Yeah.
Oh,
he had
never mind. We will jump to Mansoor.
Okay. Thank you, everybody. I'm about to... can you stop sharing, please, Sham? All right. I'm going to share my screen and my application. Hello, everybody. Thank you for coming. My name is Mansoor. I'm a senior architect at ESRI, and for the last 5 years now, I've been traveling the globe implementing big data geospatial solutions. Again, you can reach all my colleagues and, of course, me, and you can see a lot of the stuff that I've been doing at Thunderhead Explorer. So if you want to take 2 minutes of your time in the morning and check out what I've been up to, you're more than welcome. I'm going to be extending on sharing what has done, and I'm going to tell you what we have as a product and what me has been doing as professional services in big data, and especially when it comes down to massive computation on massive amount of data in distributed fashion and other stories like that. My big data world actually is divided into two streams, and I'm going to make this very quick. I mean, I can talk about this for infinity. But it gets divided into real-time data, which we're seeing a lot right now with the advent of IoT and IOEs and sensors and all kind of stuff like that. And we have extended the ArcGIS platform to be able to do massive data ingestion and analytics right on the fly from different social medias, sensors on the ground that are static or moving, or different flying things like drone. Something we did not talk a lot is drone is starting to become ubiquitous. We have this, one of our products here is Drone to Map, that enable you to bring in a lot of this data and help you out with this. It's an extension to the ArcGIS Enterprise that Chan talked about, and it's in the form of GeoEvent, and we've added new spatial temporal capability analytics to do that. And of course, all that is pushed up through the same scenarios that Chan was talked about on web devices and desktop, to be able for you to visualize and consume and experience all that scenario in there. You basically build in GeoEvent your models using a flow diagram. And you can bring in different capabilities such as filtering and processing, and all that will be distributed and parallelly executed. So you just have to design your workflow, and then we will take care of a lot of these infrastructure. For example, this is a workflow of tracking an ambulance that is coming into the hospital, God forbid, and it's looking for dangerous area to speed around, make sure that he's not going too fast, or keep having a monitor to proximity to the hospital and alerting that something is coming in. So you can design these workflows like that, and then we will distribute them onto GeoEvent. And from the events that are coming in, they will get pushed out and visualized on the map. As I said, we can look at moving data, planes, trains, automobiles, hospitals. We can look at stationary data, gauges, weather station, traffic, and of course we can look at discrete events like crime happening, lightning, and of course all that is overlaid with geospatial data to get better insight from the whole thing in there. We've extended the ArcGIS platform with a spatial temporal big data store, because traditional relational data store, shapefile, or other thing cannot handle massive amount of data. But also at the same time, we need to be able to turn around and retrieve it and visualize it and query it on any attribute, spatial, temporal, or regular text or number or date. All these things have to be able to happen. So we've added in 10.5 our big data spatial temporal capability to scale up to multiple data nodes. You scale these horizontally on inexpensive hardware, and you can purge it onto your big data stores that is not needed continuously, such as Amazon S3 or Hadoop HDFS or your own file share if need be, and you can bring them back into that. And we have a very smart way of creating smart snapshots that is, for example, temporal, in such a way that we can quickly partition through data. So we can now store massive amount of data, query it, and do it in a very, very intelligent way. Of course, because we do maps a lot, we need to be able to visualize this whole thing. So one of the things that people are expecting us to have is to have spatial indexes all over the place. Actually, that is not the case. We can take advantage of dynamic aggregation of data, because we can do it so quickly, and we can do these things on the fly on millions and millions of records. Typically, people will start aggregating in temporary placeholders the data they've been receiving, so like that they'll be able to query it, analyze it, and stuff like that. Actually, that's not the case anymore. We can now start querying on the fly and aggregate on the fly and visualize on the fly these different criteria. And we can visualize by hexagons or square. I love the hexagon tessellation, which gives us a really beautiful, smooth effect of visuals, which I really like about. And of course, we can take advantage of different projection to handle that, because not everything is Mercator and everything that we deal with, and I'm sure you're familiar with that. We've added even additional real-time capability to handle, for example, dynamic heat map generation. So now you can have a combination of both. You can have a combination of heat map that is dynamically flowing. I call these space-time ripples. I'm going to talk that a little bit later, and be able to visualize that information coming in on the screen. Some very cool, what I call expressive maps. Now, as you can see on the left-hand side, we bring in the IoT. We have the big understanding in the middle with the spatial temporal. And of course, we extended with something I think you guys are interested in, with this, what we call the geoanalytics server. The geoanalytics server is intended to process feature data. Steve's going to be talking about raster data. I'm going to be talking about feature data on how to process millions and billions of records that were hard before to do. So we've taken the same concept that we're familiar with, which is geoprocessing, and we basically extended it out to become parallel distributed shared nothing scenarios. And this is if you get to see me, I have no hair, is because I literally been pulling it for the last couple of years on how to rewrite my serial algorithms that we're so familiar with, and then rewrite them in parallel distributed shared nothing. And it's a thought process. The algorithm itself is the same on concept, just implementation. We finally figured it out. Actually, we use a lot of Spark in our and what I do and stuff like that to be able to do this massive distribution of parallel processing on this massive amount of data. But to keep my ESRI hat on, we still federate it, we still bring it in through the portal, because that's the best way to register this data, be able to other people to consume it and share that knowledge that you've done with other people, and of course visualize and the whole thing in there. So again, things that are too bad, like billions of observation of ship movements. We did something for fraud detection when we looked at billions of transactions for fraud detection. Again, if you look at some of the user conference videos, we talked about that. And again, things that used to take forever to do now can be done by scaling horizontally, adding more parallel compute to the process. And we've taken this, we did not implement everything, we've taken the hard stuff. For example, how to aggregate points. You saw that hex binning, how to do things that are within each other, or how we reassemble tracks. But my favorite is we've taken the density analysis, to look for data patterns, and what we do that, we don't do heat maps, we do hotspots, right? And there's a big difference between heat maps and hotspots. Heat maps are just points that are aggregated and you just put a nice coloring scheme about it. But how are you sure that this is not a random event? This is what we do, hotspot analysis, because we give you the statistics around these hotspots, with these heat maps, call them hotspots, and how confident that this is not a random event. That's what makes us so good, and to really takes us to the next level in doing all kind of very interesting analytics. By the way, the data does not have to be only in ArcGIS platform. I've seen people that want to bring in data from their data sources. And again, you don't have to copy the data into the system. That is, say, okay, this was good in the old days when you have a shape file and stuff like that. Well, when you're dealing with billions of records, that's just not possible. So we make you register your Hadoop, your HDFS, your file systems, your Hive table if you want to, and then we register them, and then we can now start doing deep analytics on them and push back the result through the portal to be for you to be consumed through, for example, Python notebooks or your own API if need be, through the REST API to visualize the whole thing, which makes it really, really nice. So you can get started with out of the box. We give you the same experience that is on Pro or desktop or on the web. And if you, like what we said, if you love to come down to Python or R, you have the experience to do that, or the REST API, which is good. The aggregation that we do is space and time. It's not just spatial, but temporal. We do that, again, through these space-time cube generation. And we can do these massive spatial jumps. Again, something very interesting here. I don't need the data to be indexed to be able to do a billion by billion polygon intersection. This is something like that's totally brand new, right? In the old days, you had to put it in Oracle Spatial or in PostGIS and index it to be able to do that. We do not need to do that because we take advantage of pure parallel compute to do these scenarios. And we do that not just only by space, but we also do it by time to be able to cookie cut data. And we, of course, we visualize in these beautiful, beautiful expression maps that I showed you about, not just by aggregation, by hexagon square, but also we can turn around and take, for example, demographic data like the living atlas data and fuse it in to really give you the insight that we need. Pretty cool stuff. I don't know if you can see that visual happening. This is 170 million lightning strikes that we saw through Texas as they're going in. And you can see the storm moving in by these aggregation because the data is space and time aware, which is very, very cool. Anyway, just wanted to share some of your stuff. The analysis that we do, some of it is, for example, is track reconstruction when we look at storm data, or if you're tracking bad guys by three-letter government agencies, you can re-aggregate all this data and visualize it all on the map and turn it into beautiful, expressive maps to give you insight into what is happening on patterns in recognition and stuff like that. We run these, and we've ran these analysis on typical 16-node cluster. These are commodity hardwares, believe it or not, which we brought from our warehouse. We clubbered up together. Or, you know, we've done it on craze, by the way. So we went from classic commodity hardware where we put together, form a cluster and then ran analytics, to actually a cray where we took the analytics, ran it on a cray. So that's the beauty about our analytics. They can go either spectrum, which is awesome. We're processing, again, 4 billion data points in a couple of minutes now, be able to perform spatial join. These are things that before we could never do. Now we can say they're commoditized and we can do that scenario in there. Okay, check out the video for the user conference. I know we're short on time here. Check out the video for the user conference where we showed a 1 billion by 1 billion spatial join without spatial indexing. These are fascinating stuff that we did. So I want to leave you with a couple of more things here. We have open source to the community, GIS tools for Hadoop. Do not be fooled by the word for Hadoop. There's some really cool nuggets in there. If you like programming or tinkling, which I think you are, tinkling, you guys can look at this library, some very cool stuff that we put on GitHub. You can download the source code for it, try it out, and see some really cool things. Like one of them is the geometry API for Java, if you're a Java programmer, because practically everything that we do in big data is, a lot of it is Java, but we're seeing Scala, we're seeing Python, we're seeing R, but this one is for Java. And then if you wanna do things in Hive, if you're interested in doing that, we've extended Hive with OGC type of capability so that you can do things that were hard in Oracle Spatial or SQL Server, but now you can do them. I'm not saying that you can do it fully perform it, but before things would fail, now they will be actually applicable and you can do them right now. And of course, shameless plug. This is me on the lower right corner here. This is me, Mansour. Check out my blog. I blog a lot of these ideas inside the platform and outside the platform, how you do massive parallel computing and distributed stuff like that. So check me out. And of course, I will not be blogging on big data. In fact, don't throw in the famous words here, which is machine learning. Of course, we're getting into this right now. So check out what I'm up to and what we are doing. Okay. So thank you for your time. I know we're running short. I'll hand it over now to Steve for his raster analytics.
Thanks, Mansour. Can you unshare? Thanks.
Yep.
Let me share that one. Okay. Okay, so I'm going to talk briefly about the raster side of the analysis. As Mansour was talking about, we have tools for feature and tabular big data processing. We also have some new capabilities for big data raster processing. So for building and executing raster GIS analysis or image processing chains and models. Here again, distributed storage and distributed analytics. So one of the biggest problems with big raster processing is a lot of the analytics are often not particularly complex, so you end up being IO bound. So the first thing that we did was developed capability for doing distributed storage, and then developed new distributed analytics tools to work against those. Somebody needs to mute. I'm not sure who it is. But... So sort of typical raster GIS and raster analysis capabilities, a large collection of traditional local mathematical operators for doing simple mathematical analytic models, a lot of data management tools for things like converting LiDAR data to raster data, doing interpolation, reprojecting large collections of imagery, converting between feature and raster data, etc. some image processing and image enhancement tools for doing geometric corrections, pan sharpening, segmentation, image classification, and things like this, as well as what you might think of more as sort of traditional GIS analysis, doing weighted overlay, suitability models, distance analysis, additional interpolation tools, zonal statistics, surface analysis for just calculating things like slope, aspect, curvature of surfaces, doing viewshed analysis. We have a really efficient GPU-based viewshed tool that works in a lot of different areas in the world, already hosted into a service. And then obviously we've mentioned a few times the Python aspect of it, and for the raster component, not only is Python the way to orchestrate the system, but Python is also a way to customize the system. So if we don't have an analytic function that you're looking for that happens to live in a Python library you're interested in, there's really nice hooks for connecting those into the system, connecting those up with our tools, and then executing those on the distributed environment. Similar to the way that it works with the things Mansour was talking about, it all lives in a portal. We have a collection of data and web layers. Using ArcGIS Pro or the developer API, we would construct an analytic workflow or a model. Maybe it's using Python. Maybe I'm using the graphical UI. But that model gets distributed to a collection of distributed processing nodes. Those processing nodes can read not only from our distributed raster data store, but also traditional sources, ArcGIS data services, OGC services, folder full of files, geodatabases, etc. And the results of those are written into that raster data store in a distributed way. And then the results of those are automatically made available as new WebGIS layers that can be displayed. So you don't actually create a new data set and then have to author a service for it. The authoring of that service and the ability to share it external to the organization as a web map or whatever is basically just part of the workflow. It just happens. You don't have to author services every time you create something. The other thing you can do to speed up your executions is you can take any of these data sources that you have and import those into the distributed raster data store to optimize computations. So a couple of examples of things that we did in testing out some scalability of this. We took the global 90-meter SRTM data and ran it through a terrain suitability model, about 15 or so analytic steps. This is the entire world at 90-meter resolution on 8 cores, and did a scalability test to it. We run it on a single processor. It took 13 hours, and you can see the performance progression here. At 16 cores, 16 processors, we're down to 80 minutes, and we're pretty comfortable with the idea that if we scaled that out to 32 or 64, that would continue to go down similarly. We also did a sort of classic GIS suitability model for looking at solar power, combining a whole bunch of layers of landscape characteristics and structural characteristics, slope, solar energy potential, proximity to different things in the landscape, existing land cover, and other characteristics. We combine all of those together into a weighted overlay model at a 30-meter resolution for the entire country, running 8 cores in Amazon. If we run that on a single desktop machine, it took just a little under 6 hours, and that's single-threaded reading and writing a whole bunch of 30-meter resolution data for the country. If we use the distributed data storage and raster analytics project, we can execute the whole thing on 56 processors in 7 minutes. So, and then last example, we did another Amazon project. This is using some data that's available on Amazon. We did full collection of Landsat, so 7,422 30-meter resolution scenes sitting in Amazon S3, running 200 processors for each scene, creating a no data mask, doing a top of atmosphere correction, a modified soil adjusted vegetation index, and then remapping that into a set of categories or classes, and then writing out a new data set. That whole thing ran in a little under 3 hours, which seems, well, it's 3 hours, that's a long time, but it's cranking about 44 scenes a minute. And if you remember back to 5 or 10 years ago trying to process Landsat data, 44 scenes a minute is pretty quick. So just to give you an idea of a few of the things that are possible, and I know with the hardware that you guys have access to, doing 200 cores or 200 processors might still seem small, so we encourage you to try to do something bigger. We're getting kind of close on time, and we wanted to have some time for Q&A, so I was talking fast. So what to do next to get started with using ArcGIS in XSEDE? The first is, Eric sent out the invitation to a broad audience of XSEDE people as well as GIS people who weren't involved in XSEDE. So the first question is, do you have an XSEDE allocation or do you need one? The other question is, well, I have an XSEDE allocation, but does my university have an Esri license? And who is the person at my university I need to talk to about that? For right now, Eric has agreed to field all those questions, so you can email him those questions, and for the ones that he needs to contact us to answer, we'll take care of that. In order to learn more about what's possible, there's a whole bunch of videos available. We have on our website, we have a conference every year we do called the Esri Developer Summit out in Palm Springs. And all of the workshop videos from those technical sessions are available online, are freely available. So there's workshop videos there for ArcGIS Enterprise, for the raster analytics I talked about, for all the things that Mansour talked about. They're all there. So you can go get, an hour, hour and a half about each one of those topics there. GeoNet is the sort of online social networking site for Esri customers. So there's a lot of discussion forums there about different aspects of our products and our technology and different uses of it. And I put in also support.esri.com, which is the place for tech support. And I just need to mention that for people on university site license agreements, the way that your university license works is there's a half a dozen or so people within your university who are on a list as being the people who can contact tech support. So you just need to work with your on-campus administrator to find out who that person is. But also at that site are a whole bunch of online resources and Q&As and answers to previous questions other people have had. So you don't necessarily need to be able to call tech support. There's a lot of sort of help yourself resources there as well. And then finally, I just want to say thanks and open it up for questions. All of our email addresses are here, and I guess we're just a bunch of science and software geeks like you guys, and we just want people to do interesting, relevant things with our tools. So if you did something cool with it, let us know. And if you find problems or have suggestions about how to make this work better for your application, let us know. We're really interested in seeing what you guys can do with it. So with that, let's open it up for questions. Hello?
Steve, we did such an amazing job that they have no questions.
Let me.
Let's see. So we have. There was a question from Luke in the chat window. A link to the video from Mansour on the billion by billion join. and
Yeah.
as well as links to the Dev Summit videos and GeoNet. So what I can do for everyone is I'll talk to Shannon, Mansoor, and Steve and collect the links from the slides. And I will send that along with the link to the video through all the various channels that this talk was advertised to. So if you never received an email from me, feel free to send me an email and I'll make sure that you get the information.
And those links are also in our slides. So if there's a place, if we want to make a...
Yeah, if you guys can send me the slides, we can put those online as well so you can click through. That would be perfect.
Yeah, we can just export a PDF of the slides and have the links enabled in it. Yeah, that'd be fine.
Oh, that'll work. I do actually have a question. I wanted to give everyone a chance, but if no one else has a question. So Steve, in your process flow slide, you showed the connection that I think a lot of HPC folks that maybe weren't able to join would be interested in, which is basically linking ArcGIS Pro, which is the desktop-based GIS, to the kind of analytics and enterprise backend on the cluster. Where can people find information on how to set up and configure that so that they can very easily kind of point their desktop ArcGIS Pro users and say, okay, this is how we can get it to work on our HPC center.
So what that is by setting up ArcGIS Enterprise and a portal, you end up with a collection of named user logins for your portal. And for example, I have a login to a particular portal that my team has. And when I open ArcGIS Pro, I can connect to my portal, and that portal can live anywhere, right? And it then knows, that instance of ArcGIS Pro knows how to find all of the data and analytic workflows that are existing in that server. So sitting in ArcGIS Pro, I can actually just use Model Builder and connect together a process workflow that's actually executed on my server or in my cluster. But I'm using ArcGIS Pro on my desktop as my client to orchestrate workflows on the back end that are in some remote location on a cluster. So it's not actually about setting up Pro. Pro just knows that you have a login to a portal. Everything else actually happens in the enterprise portal that Shannon was talking about.
Right. I guess I meant in terms of the instructions to set up a portal. So if somebody has, a campus cluster and they want to make a portal available, could we have a link to the instructions, either chef scripts or some kind of instructions on setting up a portal?
Yeah, sure.
I've been emailed that a couple of times before the talk, so I wanted to specifically throw that in there. But I'm gonna be quiet in case if anybody else has any questions.
Hi, this is Xingong Li, and I'm just interested has the ArcGIS Enterprise deployed on the XSEDE machines?
That is a fantastic question.
Has it already been?
Yeah.
Not that I know of. I know that it's running on Roger at Illinois, which is not an XSEDE machine.
Okay, so quick plug. Roger is a level 3 XSEDE machine. So if people would like access to Roger, they can send me an email and they can have a very quick allocation made through Roger. There are several XSEDE Supercomputing Center folks who are interested in getting the Arc products on their machines. So the big question was licensing, which is one of the reasons why this talk took a while to figure out. So I think very soon you will probably be seeing Esri software, ArcGIS running on some of these machines.
Thanks.
On a side note, last time Steve and I were up in Illinois, as a proof of concept, we were able to wedge very quickly geoanalytics on top of Roger as a proof of concept, and we did that in a couple of hours with a graduate student. We were able to put that together, and we did a small little presentation of it up there. It was a fun little interesting project, by the way.
Yeah.
Wonderful. Yeah. And if anybody wants access to Roger specifically, send me an email, and I will route you to the right people.
Yeah, this is Nancy at SDSC. We've been, as Steve alluded to, we've been trying for a while to get Esri products up on the supercomputers out here in San Diego, and I think we're at a position of doing that. It's been a matter of sorting some things out with the university licensing system. Sergio, I know, is interested in this for bridges as well. So,
yeah, we're trying. We're working with Eric and I guess with Carnegie Mellon University, who owns the license that we would hope to be able to take to bridges, and hopefully we're getting there. I think Eric said he was going to tell us who the Esri account manager for Carnegie Mellon is, and then we should be able to make it all happen. So,
Steve, when's your user meeting in San Diego this year? Is that like June or July or something?
It's July 10 through 14.
Okay, we'll try to make something happen before then. I'll set myself a goal here.
Okay, yeah.
We'll see.
That would be great.
It sounds like something good to shoot for, though.
Yeah.
Steve, another question for you. In your example, I think you use Amazon Web Services there, analyzing those about 7,000 Landsat things there. So do you know what kind of, how many computers, or what kind of hardwares do you have to perform these analyses? I think the total time is about 3 hours there.
Yeah, it was a little under 3 hours. Let's go back to that one. Let's see. They were C38XLs. So 60 gig of RAM, 32 cores, and we ran 200 processes.
Okay.
So 500 gig SSDs.
So that means about 200 computers, right?
Yeah, equivalent-ish. Yeah.
Okay.
It's more like 32 computers running 200 processes total.
Okay.
Yeah.
Thank you.
And the reason that we can, that we'll run multiple processes on a single processor is because we have the parallel I/O allows us to sort of move through a little bit more than one-to-one processes per CPU. So.
Okay, Steve, my last question. I think somewhere I saw you put the shortest path on the list in your raster analytics, capability there. I'm just wondering, do you implement that? It's pretty much the cost distance function, right? If I understand correctly.
Yeah.
So is that, do you use the gestural algorithm or a different one? Because the gestural algorithm is very hard to parallelize. I'm just
right. So the shortest path is there on the list, and that's one of the few things that you'll see in the raster analytics project that's not actually distributed and parallelized yet. That'll be released in 10.6, like later this year, and end of the year, something like that. So we have a parallelized version working, but it's not going to make it in the latest cut because we're already code froze on it. We're going to ship in a month or so, so it didn't quite make it. But
okay.
Yeah, good question though.
Thank you.
Do we have any other questions?
I see a couple in the chat. One of them here is about licensing and on AWS and cost estimates. So our model for working in Amazon or Azure is what we call a bring your own license. So you just show up with your license and say, I want, to do this. So you don't end up paying any more for using our technology. You only end up paying for the Amazon or Azure time. So they have pretty good programs, both of them, with regard to university research and giving out small allocations if you have interesting ideas of things that you want to do into the research community. And there's also some things that we're working on with Microsoft that we'll be able to talk about more, hopefully later this year, related to that.
Do you know who they should, there's a question in the chat of who needs to be asked if they have access to Enterprise. Would that be their account manager, or would they already?
Yeah, for right now, as at the end of sort of this call, for everybody who's wondering that, if you just send an email to Eric and he'll just compile all those, and we'll compile the list back and send it to everyone to let you know, does your university have the license that they need and who the appropriate point of contact is. We just decided to use Eric for a day to sort of compile all that, just to streamline it all. Question from Wendy, do I need ArcGIS portal license for each node on the cloud to do this? No, you basically have one portal license for your organization that you would use, right? So you don't need a separate portal license for each one. Do you need an ArcGIS Enterprise license in order to access raster analytics tools? Yes, raster analytics is basically an extension. It's called Image Server for ArcGIS Enterprise, but it's an extension onto the Enterprise project. Just trying to scroll through the other questions in the chat. Do we have to buy raster analytics separately? No. If you have a university site license agreement, then you basically have everything already. There's nothing additional that you would need to buy.
And just for confirmation, if let's say like Nancy or Sergio gets this running on XSEDE and San Diego or Carnegie Mellon's site license has these products, they could use them as an XSEDE user, correct?
Yeah.
Right. So
we
for those
need to clear that with David DiBiase just to make sure, but I think the answer would be almost definitely yes, no problem.
right.
And the reason for that is like 95 or 98% of universities in the US actually have site license agreements with us, or like major research universities have site license agreements with us. And because of the restrictions that you guys have on uses of XSEDE, that's very similar to our university licensing agreement as well, about using for research, using for education, not for commercial, etc. So we're pretty similar in how that's handled. So I don't think it would be a problem.
Wonderful. So yeah, if we can get Nancy and Sergio on the hook for getting it on, like something like Comet at SDSC or Bridges at Pittsburgh Supercomputing Center, that would be fantastic.
That is certainly the intention. I guess there'll be some, additional vetting, or so you would probably have to have an XSEDE account. I think that's been established. So we would, and then, we have a portal where you would say, you would use it with your XSEDE account name or something like that. And basically we would put you in a group that can, use this license. And the other thing is, as you know, XSEDE does support non-academic users also, like government and even industrial users, as long as they agree to, as long as their work meets certain requirements, like not being, competitive and being destined for publication in the open research literature. So we would probably have to not give that deal to industrial folks, is that right, or non-academics?
Probably, yeah. I'd forgotten about that detail. So yeah, we'll have to talk a little bit more about that.
Yeah,
but I think
yeah. So I mean, we do that for other software products also, is that, we, like I say, you get this web form that you have to complete, and then, if you are academic, you go to the right, and if you're not, then you go to the left. We talk some more, and we discuss with the vendor how that should be handled.
Yeah. I think in the spirit of research and education, I think everything's fine. Yeah.
So I see a couple of questions in the chat window in terms of how do we get access to XSEDE and or Roger, and does that have a cost? Send me an email. The answer to cost is it's absolutely free. NSF, U.S. National Science Foundation, supports both XSEDE as well as Roger to provide free access to computational expertise and resources. So what you do have to do is apply for an allocation. It's similar to writing a grant, except for instead of dollars, you get CPU cycles on these supercomputers. So send me an email and I can help walk you through getting a startup allocation on these machines for free. The question for students, absolutely. Students in my classes have gotten XSEDE accounts, and then they're put on my allocation, which is a fantastic way to train them. So all the students in my geocomputing classes, for example, have accounts on Roger in order for them to learn how to do this themselves. So yes, the faculty member does have to apply for the allocation, but once the faculty member has an allocation, they can add their students' accounts under their allocation. So answering Brian's question in terms of an ideal world, just request an ArcGIS XSEDE allocation. Yeah, hopefully we can get to that ideal world. That would be fantastic. And that's what I think a lot of the people on the call are hoping to achieve.
Yeah, this is Steve. I would say that is the ideal world, and that's sort of where we're all hoping that we end up very shortly. Yeah,
I like Steve's slide right here with the global Landsat processing. It'd be nice to actually rerun that or do something similar on XSEDE. I might send a follow-up email on that one.
Okay. Let me flip down here to the contacts again.
Yeah. So again, if you have questions about XSEDE or Roger, or if you're not sure who on your campus or at your institution to contact about your licensing agreement and these sorts of things, I can play the point contact. So eshook@umn.edu, and I will make sure that your email gets forwarded to the appropriate person or persons. If we don't have any other questions, I would really, I know Shannon had to run to a meeting, but I'd like to thank her and Mansoor and of course Steve for giving such a wonderful talk. We really appreciate it. And for all of the follow-up work that the talk will ensue.
No, thanks everybody for coming over lunch. Appreciate the interest. Looking forward to some interesting projects with you guys.
All right, thank you everyone.